Okay, so tomorrow's lab we're going to be splitting water, and the fancy term for splitting things with electricity is electrolysis. So the electro part, kind of hopefully self-explanatory, it has to do with electricity. And you know from biology, lysis has to do with splitting. So we're going to use electricity to split water, and because water is so important and because this process is important, it has its own name. So hydro has to do with water, and lysis is still splitting. So we are using electricity to split water molecules into their component elements. And for our lab, for our demonstration, which is also, you're going to do it on a little bit smaller scale with a little different apparatus, we're also going to be splitting water using these little tanks and 9-volt batteries. So I showed you these on Friday if you were here. If you weren't, we're going to go through it. So again, water is H2O, and water is composed of hydrogen and oxygen. However, recall that hydrogen is diatomic, as is oxygen. So that means that they run around with a buddy. So when I write the formula for hydrogen and oxygen, I have to write sub 2 because I have 2 hydrogens and 2 oxygens. Now, these are also gases at room temperature, as you probably know. So we write little g for gas, and obviously, hopefully you know that water is a liquid at room temperature. Is water a compound or an element? Compound! You guys all should say that. Come on, you guys. Okay, it's not on the periodic table, so it's compound. Hydrogen and oxygen are? So we're taking a compound and breaking it into its component elements. What kind of change is that? Chemical or physical change? One thing becoming 2 different things is chemical. Okay. Again, because of the diatomic nature of these 2 elements, we have to do a little more to our equation to make it balanced. We want to follow the law. Oops, that doesn't show very well. We want to follow the law. Find a better color. Have any good colors? Oh my gosh. That's all right. The law of conservation of matter. States that you can't create or destroy matter just because it's doing a physical or chemical change. Okay? All the stuff that's in the reactants has to be in the products. But if you look at this, it doesn't take a rocket scientist to figure out there's 2 hydrogens on this side, H with O, 2 hydrogens on this side, 1 oxygen and 2 oxygens. This isn't balanced, so we have to balance it. And the way we balance it is with, what's the fancy word? Nice. So the 2 is a coefficient when it's a big 2, and we need to have 2 water molecules to have 2 oxygens to make the 1 oxygen molecule. However, very quickly you should notice now we have, instead of having the right number of hydrogens, we have 2 extra hydrogens, so we're going to fix that with a 2 here. Coefficients are used to balance equations to follow the law of conservation of matter. Right? These are called subscripts because they're below the line, and they just tell you how many atoms of that element are stuck together. All right, so that's the process that we're going to do, but it takes energy. Okay, so we have to run electric current through the water in order to make this happen because water doesn't want to come apart. Okay. And so that coming apart is an involved process that we're going to need to use apparatus to do. So This apparatus is called the Hoffman apparatus. It has an orange background just so you can see it better. There's stoppers and these little electrodes. They're actually glass, but there's copper wire in the glass tubing, and it comes out this end. And then there's a piece of platinum at the tip of them connected to the copper wire. You'll notice there's red and black. That has to do with the electrodes, and by tradition, the red electrode is the positive, the black electrode's the negative. Has a little like a funnel thing at the top that has a liquid in it that flows through the tubing and fills up the arms. And then these are little, they're called stopcocks. They're little valves that turn when they're, what's that word? Horizontal. This is closed when it's perpendicular to the tubing, when it's in line with the tubing. This is just like any kind of gas valve anywhere, or water valve for that matter. When it's in line, in this case vertically, then stuff can flow out of it, and I'll show you that at the end. So the next thing we're going to do is make a little drawing of our apparatus, and it's a kind of tricky little thing. So start with the funnel tube. It has a little bowl on the top of it. And then it comes to a T. And that tees off to the arms. I'm just going to draw a little pointy thing at the top here. You guys are probably better drawers than me. I'm just trying to make it simple to draw. Okay. And then it's actually this way. In the bottom are the stoppers. And inside, there's the electrodes. And the electrodes are made of platinum. It looks like aluminum foil, but it's platinum. It's very non-reactive. In the tubes is a solution, and it's not pure water. So because, I mean, hopefully you guys know enough not to take electrical devices into the bathtub, but so you don't get electrocuted. But it actually takes a bit of time. So what we do is we put in electrolyte to help the electric current flow through this better. Out the bottom, I'll talk more about that in a second. Out the bottom are copper wires for conducting electric current. Off on the side is our AC to DC converter box. So we're taking alternating current from the wall and making it into direct current, which is like a battery. And it'll be 12 volts. Pressing too hard here. And on the box, the red terminal is on the right, and there's a black terminal on, the red terminal's on the left, and the black terminal's on the right. And we're going to hook up the lines to the specific sides. Now, electrons don't care what color the lines are. However, by tradition, some of you know this from working with like a car battery or something, the positive terminal is traditionally made red. It doesn't have to be, but that's by tradition, and the negative terminal is black. So when you're trying to jumpstart your cars, keep that in mind. Okay, so we got solution, electrolyte. The electrolyte is sulfuric acid. Very dilute. So there's a little bit of charged particles to allow the electric current to flow. So up at the top again are these valves that I'm going to use. I'm going to open up later to capture the gas that's going to form. So this thing's going to run for a bit, and we're going to produce gas in these tubes. So I'm going to go ahead and turn it on. Hook up the alligator clips. You're going to do something like this, but with a 9-volt battery, not a converter. I don't have the money to buy converters for everybody. Okay, and it's going to start running, and on the surface of the platinum, you'll be able to see pretty quick, well, maybe just the people in the front, you'll be able to see bubbles forming, but you'll be able to see bubbles rising up, okay? And so we're gonna let this run for a bit. I've got a candle for later, not just for ambiance. Couple things. The hydrogen, when hydrogen forms ions are charged particles. So they either have fewer electrons, they lose their electron like hydrogen does, or they gain electrons like oxygen does. And we're going to talk lots more about that here. One of the rules of chemistry, and again we'll also talk about this a lot, is opposites attract. And that means that the hydrogen ions should accumulate at the negative terminal. Hydrogen's positive. It should be attracted to the negative side. The oxygen, which is negative, should be attracted to the positive terminal. And that's going to be our predictions, okay? We're going to do something called the splint test to see which gas forms. Okay. There's two types of splints. There's glowing splints and lit splints. And I will show you both of those when we are ready to test the gases. All right, so we're gonna have to let this run for a little while. So what we're going to do right now is go ahead and move to we're going to set this aside, we'll come back to it, but we're going to go ahead and talk about the lab. Okay. So find your lab packet.